Before tomorrow's test, I want to take a moment and walk you through several examples of how we use quadratic functions to solve word problems. In the example before us, we have the relationship between height and time, or between height and horizontal distance. So let's look at example number 1. A volleyball is served with an initial velocity of 20 meters per second. So the height, h, is in meters, and the time is in seconds after it leaves the arm, and the relationship is h equals -4 times t minus 2.5 squared plus 27. Now the first question is asking us to determine the maximum height reached by the volleyball and the time it takes to reach the maximum height. So if my volleyball leaves at the time equals 0, it takes a certain number of seconds to reach the ground again. So it starts here and it lands on the ground over here. So how many seconds? So time equals what to reach the maximum point, or the vertex point as we call it. How many seconds does it take to reach that vertex point? Well, let's take a look at our function again. H equals -4 t minus 2.5 squared plus 27. I'm hoping that you can quickly see that this relationship is already arranged in vertex form for you. Now the vertex form was y equals a x minus p squared plus q. Let's compare the vertex form of the function and the relationship that is given to us. Well, I can see that a is -4, p is 2.5, and q equals 27. Now let's see how we're going to use these numbers in relation to what the problem is asking me. Well, I know that q represents the maximum value of a function. Now, what value does this function represent? It represents the height. So the maximum height that the ball will reach is 27 meters. So the maximum height equals 27. Now, when does this happen? How many seconds does it take for the ball to reach 27 meters? Well, that is a corresponding value to when q is 27, and the corresponding value is the p-value. So the time it takes to reach 27 meters is 2.5 seconds. The second question is asking you to find the height of the volleyball at 3 seconds. Before we even start, let's figure out where that 3 seconds is going to happen, before the vertex or after the vertex. Well, if it takes 2.5 seconds to reach the vertex, I'm going to pass the vertex by half more second, and that height is going to be somewhere here, right? At t equals 3 seconds. So whatever height I'm going to get for the time being 3 seconds should be less than the maximum height of 27 meters. And the way we find it is we're going to substitute time with 3 seconds. So height equals -4 times 3 minus 2.5 squared plus 27. And what I want you to do right now is solve for h by adding the numbers. Again, keep in mind that whatever this height is going to be, it should be less than the maximum height, because it happens after that vertex point. Now, let's take a look at that second problem. The second problem was telling me that a bridge is modeled by an equation. So, for example 2, I'm going to rewrite. So, a bridge is modeled by an equation h equals -0.022 times d minus 39 squared plus 34. And in the first point, I am asked what is the horizontal distance that the bridge covers. So if I have a bridge, that's my bridge, and I know it opens down because that A is negative. So those are the legs of the bridge. What is this horizontal distance that the bridge covers? Well, what do these points look to you? If this would be an imaginary x-axis, the points where the parabola meets the x-axis are called the x-intercepts. Also, what is the height of the bridge when I'm on this imaginary x-axis? The height equals 0. So let's look at our equations, and I'm going to set the height to 0 equals negative 0.022 times d minus 39 squared plus 34. Now remember what we discussed in class. Whenever we're trying to solve a quadratic equation and my variable is already contained in a perfect square, I don't want to expand and simplify the perfect square. Because whenever I want to take what's out from a perfect square, the end goal is to square root that equation. So I am going to isolate it. So I want you to imagine this perfect square is going to be isolated on one side. So then I'm going to move the 34 to the other side. So it becomes negative 34 equals negative 0.022 times d minus 39 squared. I'm going to divide both sides by negative 0.022. So it becomes, so divided by negative 0.022, and it's 1545.45. Now it became a positive because I had two negatives divided by each other, equals d minus 39 squared. Now I'm in that scenario that I want, which is square rooting both sides. So we're going to square root both sides, and square root of 1545.45 is going to be either positive or negative 39.3 equals d minus 39. So let's see what the two options are. Either d minus 39 equals positive 39.3, or d minus 39 equals negative 39.3. So if I look at the two equations, from this one I can conclude that the distance equals 78.3, or over here the distance equals negative 0.3. So my bridge starts west of the x-axis at negative 0.3 all the way to 78.3. So what's the overall distance of the bridge between the 2 points? Well, you can look at the two roots and find the distance between the two roots to find the horizontal distance the bridge covers. For the second question, 4b, it's asking me what is the horizontal distance that is covered when the bridge has a height of at least 30 meters. So if the height is 30, sorry about that. If the height is 30, what is the horizontal distance that the bridge covers? Well, I'm going to set the height to 30, and I have 30 equals negative 0.022 d minus 39 squared plus 34. Now you're in a position to solve for the unknown variable d out of this equation. So now, just like in the previous example, we're going to isolate that perfect square by moving the 34 to the other side. Now 30 minus 34 is negative 4 equals negative 0.022 times d minus 39 squared. So again, divide both sides by 0.022 and find the distance corresponding to the height equals 30 meters. Now what I want you to remember is that when I look at the bridge, the height of 30 meters will happen over here, because I know the maximum height is 34, so that is 30 meters. I'm going to draw a line. I will have two distances that I can take a look. So whenever the height is 30 meters, the first distance will be over here. So I'm going to find the first distance. And the second distance will be over here, from the beginning of the bridge all the way to that second point. So you will find that you'll find two distances that correspond to that height of 30 meters.